Hello from Berlin, my name is Maxim. I'm iOS engineer at N26. This is a mobile bank across Europe and the US. At N26 I'm working on user identity verification. And my presentation today is all about this topic. First we discuss the problems of user identity verification and why they're so critical for the business. Then we consider existing solutions for these problems and explore NFC as a possible solution. Here we take a look on NFC from the iOS perspective and learn some NFC use cases regarding user verification. So what is user identity verification? When your service like mobile banking or a car sharing service or some booking service need to verify the identity of your customers, you may ask them to take a selfie, to take pictures of their identity documents, or enter some personal data manually. All the provided user data going through some verification process, and finally your service knows if it's a good person or some fraudster. And working daily on these problems, you can see that the user verification process is not perfect. The business lost a lot of potential customers even before they start to use the service. And the problems basically come from two sides. From one side, it's the people itself. When people need to enter some data manually, it's totally normal to make some typos or mistakes. Or when you provide the best instructions how to make photos, which documents to photo or which data to enter, there is always some misunderstanding from users. From the other side, there's a bunch of technical issues. For example, the snapshots of the documents are often in bad quality. They could be too blurred or too dark or too bright, or a bad internet connection may fail uploading the big image files. The combination of all these problems has a big impact on the user growth funnel. And in the best scenario, user can retry to use to go through verification process or contact the customer support, which is always additional cost for the business. Or in worst scenario, user just gives up to use the service, and the business lost users and money. The problems basically comes from a different perspective. For example, OCR, optical character recognition technology, could replace manual data entry, or machine learning techniques could provide some hints how to make correct photos. But these technologies are still error-prone and not 100% accurate. And moreover, if you want to use not native frameworks but some third-party services, it brings additional size for the mobile apps, which is usually very painful. From other side, there's a bunch of legal techniques which can improve the situation. For example, if some data is not necessary anymore for verification in some country, you can remove the step from the process and simplify the process for the user. But as you can see, none of the solutions could remove a human factor and get rid of a technical limitation at the same time, except for the one solution that came to the iOS world recently, which is NFC. NFC is abbreviation for Near Field Communication. This is a wireless technology that allows two NFC-enabled devices exchange data between each other in close proximity. And Apple devices support NFC starting from iPhone 7. A bit of technical background of NFC. All the standards, protocols and technologies of NFC was classified into 5 so-called tag types from 1 to 5. And the difference between them basically in their technical background, like speed, security, memory and so on. And also there is NDEF as a common language between different tag types. Among huge variety of NFC examples, I think two most popular for us as the iOS community is Apple Pay and the new fancy App Clips feature from iOS 14. But I want to show you another example which is relevant to the problem we discussed today. Most of the modern identity documents like passports, ID cards, driving licenses and so on has an embedded NFC chip that contains some user data which you can read using your iPhone. So first you need to provide some input data, we will discuss it a bit later. Then you need to bring your device close to the card and you can start scanning. And by the way, all the data on this demo, besides the photo, is fake. I slightly changed the UI just for privacy reasons. And after some time, when reading is finished, we can see the we can see the data from the card on your device. And we can see that the photo in good quality is also here. That's why the reading took a bit more time because of big image file. So from first look, the NFC looks a promising solution for solving user verification problems. Let's go further. All the NFC API in iOS is inside Core NFC framework. This is a system framework that Apple introduced in iOS 11. At that time, Core NFC could read some simplest NFC text and only in foreground mode. That simplest text kind of replacement for QR codes because they just contain like kind of text message, and that's all what you can read from this text. And despite of this text could be based on different text types, we still can read all of them because of common NDEF format. And later in 2019, as you remember, Apple brought a lot of updates to the SDK, and the Core NFC got a huge enhancement as well. So now you can not only read that simple text, but also write data to the text from your iPhone. And also some iPhone models support background reading of this text. But what is really cool, Apple added support for reading some more complex text types. For example, MyFair chips used in a contactless smart cards and proximity card. Proximity card means the card that could be read from close approximately like up to 10 centimeters. And this text basically used in such services like access cards or micro payment services and so on. The Felica chips are produced by Sony and they mainly used in Asia. This tech types has a wide range of functionality, and that's why this kind of tech type is more expensive than other tech types. These tech types used in such applications like public transport tickets, electronic money, electronic ID cards, and so on. ISO 15693 standard is for vicinity cards, and this vicinity cards is cards that can be read from a greater distance than a proximity card. For example, 1.5 meters distance could be enough to read data from this card. And this tech type is popular in such use cases when you have a big distance between a reader device and tech. For example, large storages or public or libraries with books, when you have more bigger device from reader device to the cards, to the chips. And the one change in iOS 14 regarding Core NFC, besides some syntax changes, is about this standard. So now you can do even more operations in iOS 14 with this tech type. But our interest today is to ISO 7816 standard, because this standard related with electronic identity cards. It means starting from iOS 13 we can read text from passports and identity cards. Using Core NFC is pretty straightforward, and we will go through the key steps of reading ISO 7816 standard. But if you want to read some other tech types, they slightly differ. The steps slightly differ, but basically the idea is the same. How to read ISO 7816 standard. So first you need to provide capabilities in your project for NFC. It's like the same way as for some other Apple features. Then you need to update privacy description in info police, and then you need to add the application identifiers also for police file. And the application identifiers is It's kind of every NFC use case has their own identifier. For example, if you want to read biometric passports, then we need to provide this identifier to our project. And the same way, if you want to add some more use cases to our project, we can add more identifiers to the list. Using API is also pretty straightforward. First, we need to create a session, and there's two types of session in Core NFC: one for reading simplest NFC tags, another one for reading more complex tag types. As you want to read ICO 7816 standard tags, we need to select tag reader session. Here we need to specify polling options, and we need to select this polling options because this one is compatible with ICO 7816 standard. And the delegate method is also pretty straightforward, and when we setting up them, we can start our session, and here we bring our device close to the card. Here we have a 60 seconds time frame to detect NFC tags and perform all necessary operations with them. And when the tag is successfully detected, this delegate method is handled, and here we need to connect our session to the detected tag. And if we take a look on levels of implementation, you can see that Core NFC as a system framework provides us a channel to communicate with NFC tag, but all custom use cases like reading data or some other use cases should be done on our side. And for that we have this API in Core NFC. We need to create a so-called APDU command, application protocol data unit command, provide some instructions and parameters with this command, send this command to the tag, and wait for response from the tag. And when tag responded with APDU response, we do the next steps, like maybe send some other command to the tag. And all structure of APDU commands is described in ICO 7816 standard, but all the sequences of commands, all instructions and parameters of these commands, they described in doc 9303. This doc is the documentation is provided by International Civil Aviation Organization, and this organization is responsible for documenting basically everything about travel documents. And the main use case we wanna use is we wanna perform is reading data from the cards, but before we start to read the data from the card, we need to get access for reading the data. And all the data on the card is obviously sensitive because it's personal data, but some data could be considered as less sensitive. For example, document number, name, date of birth, and so on. And some other data could be considered as more sensitive, for example, fingerprints. And to get access to both data types, we need to provide different access control for both data types. So first, basic access control, and as we saw in the demo, before we start to read the data, we need to provide some input data, and this input data basically it's data, it's a document number, it's date of birth and date of expiration of document, and these three pieces of data forms the password, and with some symmetric cryptography, the reading device can establish secure messaging with the card and start to read the data from the card. Today, this mechanism is basically almost replaced with password authentication connection establishment. This mechanism is based on asymmetric cryptography. It doesn't depend on the length of the password, and it means that instead of this long three pieces of data, we can use a card access number, which is also displayed on the card. And today, if you want to implement your solution for reading data from documents, most probably you need to support both of this mechanism, because some older documents could support only basic access control. Most of the documents today could compatible with both mechanisms, but even new documents, for example, issued in last year or this year, could support only password authentication connection establishment. And talking about extended access control, we can see that here we need to both sides should authenticate each other. So chip should authenticate reader device or terminal, and terminal should authenticate chip. So chip authentication based on key agreement protocol, and we will discuss this mechanism a bit later. And the terminal authentication based on terminal certificate, and this certificate should be requested from the government. And if your service wanna implement extended access control to get access to more sensitive data from the document, you need to request this certificate from the government. The signing chain of this certificate looks like this. So eventually, terminal certificate is signed by country verifying certificate authority, and the private key of the certificate is stored on the card. And the reading device should provide its terminal certificate to the card. Card can verify if it's a valid certificate with its private key, and then card send some challenge to the terminal, and if terminal is able to sign this challenge with correct terminal certificate, the card can be sure that exactly this terminal owns exactly this correct certificate. And this is how both types of access control looks like, and they're both described in this doc 9303. But if the document is not complied with this documentation or complied just partially, then it's not necessary the case to read the data with these both access controls. For example, German identity documents like German ID cards or new German residence permit issued since the last year, they require extended access control even for less sensitive data. So it means if you want to read even less sensitive data from these document types, the basic access control is not enough to do this. Regarding the documents from Netherlands, as I didn't work with them personally, but as far as I know, all passports, identity cards, and the driving licenses in the Netherlands compatible with doc 9303, so you can set up both. You can set up basic access control to read less sensitive data from these document types. And when we set up the access to the card, we can start to read the data. All the data on the card stored in files that calls data groups. There are 16 defined data groups in doc 9303, and the two first data groups are mandatory for documents. So if document compatible with doc 9303, then this document must have to these data groups on the card. So first data group contains the data which is stored in machine readable zone, so data displayed on the card like name, document number, country, nationality, date of birth, and so on. Second data group contains face image, which is also displayed on the card. And the other data groups are optional, they can be presented or not on the card, depending on the document version, issuing country, and the document type. But most probably you want not just read the data from the card, but also be sure that the data on the card is official one and signed by the government, and also want to be sure that the card is original one and not a copy. And let's take a look on both of these use cases. So first, authentic verification, and besides the data groups, we also can read so-called security object document file from the card. This file contains hashes of all data groups, and this file signed by the official certificate. The signing chain of this file is similar to signing chain of terminal certificate, which we just discussed. So eventually, security object document is signed by country signing certificate authority, and the public key of this certificate is available publicly. For example, on the website of International Civil Aviation Organization, you can download this public certificate. And using this certificate, reading device can perform passive authentication for security object document and check the data integrity in this file and on the card. And for example, if this file is signed not by the official certificate, or if some data was changed, it means if the card was tampered, then the passive authentication will fail, and the terminal can define that something wrong with the data integrity on this card. The idea behind clone detection is that the private key of the card stored in some special secret memory on the card, and this memory is not available for reading or cloning. And it means if someone decides to clone the card, the private key can't be the same as the original one. So to detect cloning on the card, you just need to detect if the private key on the card is original one or not. For clone detection, there are two common mechanisms. One of them is active authentication, and another one is chip authentication, which we already know from extended access control. But first about active authentication. So the active authentication mechanism is similar to mechanism of terminal authentication, but in a reverse way. Here, the terminal need to authenticate the card. For that, terminal reads data group 15 on the card, and if the data group exists on the card, that means card support active authentication mechanisms, and the terminal can read public key for active authentication from this data group. Then terminal sends some random challenge to the card, and if card able to sign this challenge with its private key, then the terminal can be sure that the private key on the card is original one, and therefore the card is original one as well. The chip authentication is, as we already know, is based on Kerr-Green protocol, and for that, again, if this card support this mechanism, then data group 14 contains some security options, some security features for this mechanism, and the terminal read the security options from this data group and establish public-private key pair and establish secure messaging with the card. And if secure messaging is established correctly, if this communication is set up with the card, then the terminal can be sure that the chip has original private certificate, and the card is original as well. And as we know, these data groups are optional. It means some cards could, the data groups can be presented on, not be presented on some cards, and it means that this mechanism not supported by these document types. But basically, at least one of these, or even both of these data groups, placed on the card, and most of the documents support at least one of these mechanisms. And coming back to verification process, we can see that NFC can improve this process a lot. So now users don't need to enter data manually, because we can read this data from NFC chip on the card. And also users don't need to take pictures of identity documents, because now verification can be gracefully improved with some security mechanism which we just discussed. And most probably you still need to ask your user for selfie, but as we know, we also can extract the photo from the document in good quality. And it means we can improve this part of this, NFC can improve this part of this verification as well. And all of this thing should be implemented on our side, and most probably, if you want to do it in production, most probably you want to do it on your backend side, because of front-end side is kind of not secure, and it can be easily compromised. And most probably you will just, in production, you will just read data from the card with your device and just send this data to the backend, and the backend will do all this verification magic on the backend side and just maybe return some response to the device, like if verification succeed or failed. Also, there's a nice open source project which I highly recommend you to check. Here you can see how to use Core NFC to scan identity documents, how to implement such mechanism as basic access control, passive authentication, active authentication, how to read some data groups from the card. So all these things currently implemented in this repository. So I recommend you to check this. To conclude, we can see that identity verification process is not perfect. There are some problems, and NFC can be a solution for these problems. In iOS, all the work is NFC based on System Core NFC framework, but such custom use cases as reading document data or verifying authenticity of documents or detecting cloning should be implemented on our side. For that, we can use Doc 9303 because it contains all details of these processes and how to implement them. And also, open source project can be used to deep dive to the topic. And that's all from my side. Thank you very much for your attention. I will be very happy to answer on any of your questions, and for any discussion regarding NFC and so on, please approach me on Twitter. Thank you. Looking forward for your questions. Hey, thank you for your attention, and hope you enjoy the presentation. And yeah, if you have any questions, please type them in the YouTube chat or in Slack channel. And so far, I can see there's some comments or notes. Let's see. Yeah, we have some questions. And the first question from Bart: if a person gets a new passport, is a public key the same again? As can use belong to the same person as before? I guess the question regarding country signing certificate authority public key, and yeah, as far as I understand, this public key is updated like from time to time, and if you need to verify the passport for this document, then you need to get new keys from time to time. I think so. As a question from Mario: is there a way to prevent a reader to read the document? Probably yes. Some of document types could have this opportunity to block this opportunity to read the documents. Maybe some countries support this mechanism, but basically I think it's by default it's open. It's like everybody can read, and also it depends on the basic access control. Let's say if it's basic access control, then to read document you need to provide some piece of data to be able to read the document. So from this site, I think so it depends on the mechanism. If basic access control is available, then a reader can use this mechanism to read the document. I hope I answered your question, and Mario, if you need more clarification, please let me know. Let's check the chat from YouTube. So the Renz comment: I have no use case for checking identity documents, but I still like this talk just to know how it works. Thanks, Renz. And yeah, exactly. This is, I would say, not a very popular topic, maybe like Swift UI or Combine and so on. But yeah, it's good opportunity for us as a community to know about this opportunity. And yeah, if there's some similar use cases in your project, that is good to know. Good to know about this opportunity. Yes. So thank you for your comments, guys. And yeah, a question from Marius. So you need approval from the government to even be able to read these documents. Again, it depends on the which data you wanna read. If you wanna read you remove this two first data groups like basic data and the photo on the document, you don't need yeah. By default, you don't need any approval from the government. But there are some exceptions, like as I mentioned in the presentation, German identity documents, German ID cards, German residence permits, especially new German residence permit issued since last year. They doesn't comply with Doc 9303 comply just partially, and some they don't support some like this mechanism like basic access control, and they required some additional authentication to read the documents. So it means like for at least for the document types, as far as I know, you need some additional certificate from the government. But basically, you can read any documents. Most of the documents by default can be read just with basic access control. Question from David: do you use this method in your onboarding at N26? Yeah, good question, and I would love to share more information, but unfortunately, it's private and so on. Yeah, we are looking on this direction about NSC verification, but unfortunately, I can share it today. A lot of knowledge about how we use it, how we're gonna use it. Question from Bart: and you did this using only the Apple private core NSC? Yeah, native framework from Apple Core NFC provides this opportunity to set up the channel with chip on the card, and all other things like reading data, doing this basic access control or extended access control should be done already on your site, and for that you need to use Core NFC API, but it should be done on your site. But basically, yes, it's totally enough to use Core NFC API. So native API is enough to get a connection with the chip on the card. Okay, thank you, Bart, for repeating the questions. Yeah, I guess I answered both of the questions. And a question from Mario: any link telling which country support what is their document in EU at least? I would say no. There's no there's like a general map, and you can see like this country support, this country doesn't support. But yeah, no like common place when you can see which document support and which not, but you need to go to some country-specific authorities and check what they support regarding NFC, regarding passports and identity documents. But I would say there's a couple of good reports from some third-party providers who provide this feature, and they provide some kind of information regarding the countries, regarding which country support and which document support in this country. So I guess I can share some links later in the channel, and for these reports, and you can see you can check these reports, and I would say it's quite pretty useful to understand at least how it's popular in the world, which kind of documents, which kind of country you can support with this opportunity. Now I can see no more questions yet. And just in case you will watch my video in in recording or later, and you would like to, you just can ask more questions again here in Slack, or reach me on Twitter, or put some comments on YouTube video. I can answer a question later as well. So last call for questions. Okay, no more questions, I think. Thank you very much again for your attention and your questions. And yeah, for any more questions, please approach me. Thank you for your time. Have a nice evening. Bye bye.